Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Here we are from group 4. We will discuss about mathematics for physics, the topic for graph. The member of our groups are me, Ghevira, Syaharani, Aulia, Muharam, Irma Dwi Saputri, and Jihan. So without any further ado, let's jump to the first topic that we will discuss. The first thing that we will discuss is about translate information between graphical and numeric forms. Before that, we should know that general graph forms. The first, we have a general graph linear, where the equation is y equal to mx plus c. This equation is the equation of a straight line with gradient m and intercept c on the y-axis. Here, m is the gradient, and the c is equal to y, where the value where the line cut the y-axis. So here, cut the y-axis, and then this number c is called the intercept on the y-axis. So the second forms of the general graph is quadratic. Actually, there are two quadratic forms. The first one is the positive quadratic, and the second is the negative quadratic. So this graph is a form of a quadratic functions is a U-shape curve. We can see that here is the U-shape, and it's called parabola. The equation for this graph is a y equal to ax squared plus bx plus c, where a should be more, where when a more than 0, the curve will opens up, and the vertex shows minimum value. And for this form, A, B, and C here is a constant, and the A not equal to 0. So for the next form of quadratic is the negative quadratic. Here we can see that the difference is the value of a was negative, which actually is less than 0. So because of the value of a is less than 0, the curve is opens down, and the vertex, where vertex is the extreme point, or we can say here is the vertex. Is the extreme point of the curve. It shows a maximum value for this form. Okay, and there are other forms that use of the general graph. So here is the equation is y equal to k per x, or an inverse square y equal to k per x squared. Here is the form of the graph. And the next we have this form exponential growth, where the equation is y equal to a e to the power of lambda x, and the last is exponential decay, y equal to x to the power of minus lambda x. So that is the general forms of the graph. So the key point of the translate information between graphical and numeric forms is that a key feature of any line graph displaying a relationship between two variables is that the gradient of the curve represents the rate at which a quantity is changing. The steeper the curve, the more quickly something is changing, and vice versa. The swallower the curve, the more slowly the something is changing. So that was for the first topic. And the second topic is we should understand that y equal to mx plus c represents a linear relationship. So here we should know that a linear relationship can be written as y equal to mx plus c, like in the title, and where m is the gradient of the line and the c is the y-intercept of the line. This for the example, we should know, other thing that we should know is where a or m is positive, represent a line going up from the left to the right, where m is negative, represent a line going down from the left to the right. So when we sketching the graph, they should always start from the y-intercept, and then we can use the gradient to determine other point on the other group. So other point is basically for make the line is more clear to see in the from the variables. So we have the example here for from relationship between the velocity and time. So basically, the real form of the relationship between the velocity and time is v equal to u plus at, but we can change the form into this form, v equal to at plus u. So the form is same like y equal to mx plus c. Then after that, over here, imagine that we have a particular relationship and v equal to 0.2 t plus c, when here 0.t is the gradient or the value of m, and the c is 3. Okay. To sketch the graph accurately, in fact, start from the y-intercept. In this case, is 0.3. Okay. Here is 0.3, and the gradient of 0.2 means that for every horizontal step of length, when the graph moves up 0.2. Hence, another point of the graph is 3.2. So here we got 3.2 was from the equation where 0.2 equal to t, where here the t is 1. Wait a minute. Oh, where the t is 1. Yes, the t is 1. So 0.2 is multiplied by 1. I'm sorry. And plus 3 here. And the result is 0.2 plus 3. So the result, the value of v is 3.2. So here we got this point. Yeah. So here. Okay. So the next thing that we will discuss is about plot two variable from experimental or other data. So like what we discussed before about the translating the data, it's the relationship between the two variable. Here we have two variable. So it's the variable of the volume, and here is the time. So we have the data here. When the time is 0, the volume is 100. So the first point is here, and the time is 0, the volume is 100. And for the when the time is 1, the value of volume is 96 here, and so on and so forth. So here we can change the data into the graph by using this plot tool of variables. For this example, we have volume and we have time. Okay. Wait a minute. Yeah. And for the last that we will discuss here is determine the slope and intercept of a line graph. So here we want to find the y-intercept of a linear graph and find the gradient of a linear graph. So there's a formula for the gradient. When gradient or m is equal to rise per run, where rise is represent a vertical step between 2 points. Vertical, we should remember it's about vertical between 2 points, and the run represent the horizontal step. Here we should know that for the run is a horizontal step. Both of these quantities could be negative and care has to be taken in these cases. In physics, we can use this formula to find the initial velocity and acceleration from a constant acceleration graph. So we know that. So here we have a graph where the y-intercept is 0.3, hence the initial velocity is 3, and the x-intercept is 1.5. So we know that rise is a vertical value, so here we have 3 minus 3 here, and we have run, point of run is 1.5. So the rise here is so the value of rise here is minus 3 and the value of run here is 1.5. So the acceleration point is 2 meter per second to the power of minus square. So for the next topic that we will discuss will be represented by Irma. So Irma, time is yours.
All right, Ghevira, thank you very much for your time. So, okay, we move to the next topic about the graph. This is a calculate rate of change from a linear graph. Okay, to find the y-intercept, learners examine where the line crosses the y-axis. To find the gradient, the following concept can be used. So, this is the formula. This is a gradient equal rise over run. Okay, as we know that Ghevira was explained about this, gradient is equal rise over run. So we move to the next page, please. Okay, we will to examine the velocity is to time graph representing an object moving under a constant acceleration. We were now about the relationship between velocity and time is of the form. The formula is v equal u plus a times t, and hence the y-intercept is u and the acceleration is the gradient. So we can see the graph here. This is a velocity of an object. So this is time per second, and this is we know velocity. So this is a formula of acceleration. The y-intercept is 0.2, and also we know that this is a 0 and to because to lead in y-axis, and thus the initial velocity is 2 meter over second. So to find the gradient and hence the acceleration, choose another point on the line. The obvious choice is the point on the x-intercept is 10.0. Is 10. We know that is 10 because 10 is the x-axis. So we write it for the first. The rise is -3 as to get from 0.2 to 10.0 requires a drop of 2 and hence a rise of -2. Okay. So this is the next. This is a draw and use the slope of a tangent as a measure of a rate of change. For linear graphs, the gradient is the same through and hence the rate of change is easy to obtain. For nonlinear, a tangent has to be drawn to approximate the instantaneous rate of change. And also, nonlinear graphs have an ever-changing gradient and hence the rate of change will change from point to point. So maybe we move to the next page. Please. Okay. The example, the following graph representing a relationship between velocity and times. To find the instantaneous rate of change when t equal 3, a tangent has to be drawn. Okay, this one is to find the gradient. 2 points are selected on the tangent, and through the race of run calculation, the instantaneous rate of change can be found. Okay, from the data, we know that this is 2 points on the tangent lines is 1.5 0, and also the second one is 4.15. The gradient and instantaneous rate of the change at 3 equal 3 can be determined. A is acceleration is 15 15 less of 0 and over 4 less 1.5. So this is equal 6 meter over second. I'm sorry. Okay. Is this distinguish between instantaneous and average rate of change? Instantaneous rate of change itself is to represent the rate of the change at a given moment or place in time or space. So the average rate of change is exactly that, an average rate of change taken over the global domain. So for the next, okay. For velocity, it is given by average velocity is equal final displacement, initial displacement over change in times. This could be vastly different from the instantaneous velocity and is representative of the whole motion rather than the rate change at a given time. Average velocity can be counterintuitive. So this is a description about that. So this is an example. When we imagine a racing car driving around a track of 10 kilometer length, after completing 40 laps in 2 hours, the car crosses the start of the finish line. The average velocity during the race would be 0. While at no point during the race, the instantaneous velocity was 0. So we can conclusion that velocity and displacement are vector Therefore, they have a direction. Displacement in opposite direction do cancel each other out. And also, the path the object follows between the initial and final position has no influence on the average velocity. For the last one is speed is a scalar. Okay. So many description about it. I'm sorry, but it would therefore be incorrect to say that the racing car in the example above has an average speed of 0. The path follow is important here. The distance traveled is per 100 kilometers into hours, giving an average speed of 200 kilometers over hours. Okay, as in the example of the previous example, the instantaneous velocities at times that we know that t is equal 0, 1, 2, 3, 4, and also the velocity we can get the 0, 1, 4, 9, and 16 respectively. The average acceleration is, so average acceleration equal dv over dt. Okay, this is 16 less 0 over 4. So we get 4 meters seconds, which is representative of the entire motion. The instantaneous acceleration continuously changes and cannot be found by taking a simple average. The method learner are expected to be familiar with this plotting graph, a drawing tangen, as we was discussed before. Okay, this is the last part. Understand the possible physical significance of the area between the curve and the x-axis, and be able to calculate or estimate it by graphical method as appropriate. This is a lot of description. There are a number of points to be made of this. Firstly, in the context of kinematic or velocity time graph, when v is negative and thus below the x-axis, this represents a negative displacement vector, but a positive distance travel, we know it's scalar. So for the next, hence, if displacement is so, the sign is to be respective, but if a distance travel is required, the absolute value is taken. Also, without a thorough understanding of the fundamental theorem of calculus, differentiation and integration are inverses of each other. So finding the gradient and then finding the area are inverse to each other mathematically. Okay, this is a formula for velocity. Exactly, velocity is equal ds over dt. It means distance over time. So this is effectively a rise overrun calculation for the gradient of a displacement time graph. Rearrange keep ds equal v times dt. We know this formula is from the other formula before that we was discussed about. The formula of velocity is v equal ds over dt. Now, the change in displacement is given as the product of velocity and change in time. This is effectively the formula for the area of a rectangle. Okay, with height, velocity, and length, and hence the area underneath the velocity time graphs. Okay, here is a present graph. The example is to determine the energy stored on a capacitor. The following measurements were made. So this is a data and this is a graph to present it. Maybe next time. Okay, this is the explanation about the graph we were looking before. So to define the energy stored area under the curve has to be found. Since the graph is a straight line, a single trapezium can be drawn. The area of the trapezium is given by, okay, this is as we know that formula to find the area of trapezium. So area equal um 1/2, okay. Okay, 1/2 times sum of parallel sides times distance between parallel sides. So from the graph, we choosing 0.0 and 10.15 as point and filling in area. So we just fill it in this formula. That is 1/2 times 0 equal 15 times 10. So the value is 75. Appropriate unit need to be read from the graphs, not that chart is given in answer. All right. Okay, my part is to be end. So thank you. It's back to Ghevira.
Okay, for the next part, will be represented by Jihan.
Okay, we move to the next material is mathematical concept. To solve pseudo-differential equation using a graphical or spreadsheet approach. The equation is delta x over delta t equal to negative lambda multiplied by x. This is an example of pseudo-differential equation where the unknown now is a function x to be found as a function of t. Remember that the quantity on the LHS, this one, represent a rate of change and hence a gradient on a graph of x against t. The instantaneous gradients can be calculated point by point and then compare with the value of x at this point to find the value of lambda. Understanding that this equation represents exponential decay, learners can then write the relationship in the form x equal to a e to the power negative lambda multiplied by t, where a is to be found by looking at the initial value of x. Okay, next, interpret logarithmic plots. The equation for a line on a log-log scale would be log y equal to m log x plus b log k. This is the equation of a straight line. The logarithms of x and y have a linear relationship, where m is the slope and b is the intercept point on the log plot. Next, use logarithmic plots to determine exponential and power law relationship. There are two models here. The first one is y equal to ka to the power x and y equal to kx to the power n. In the first model, the variable is in the power. The variable x is in the power, and this is an example of an exponential function. And the second, the x variable as the base, and this is a power function. Okay, here we have a data to applying this model. Okay, here we will investigate the exponential model. Is p equal to ka to the power x. The aim is to find out the constant k and a. and we calculate the P by using calculator. And here the result of log P. And this is the graph of log P again X and has been plotted. And the graph will be a straight line like this. And the y-intercept is 0.3, whilst the gradient is 4.25 reduce 0.3 over 7 reduced by 0 is equal to 0.56. This value we got from before. This is 4.25 reduced by 0.3 over 7 reduced by 0 is equal to 0.56. For the exponential model, the value of k is given by k equal to 10 power intercept equal to 10 power 0.3, this is, and equal to 2, whilst a is found by a equal to 10 power gradient equal to 10 power 0.56, this is the gradient, and equal to 3.63. Hence, the model is written as P equal to 2 multiplied by 3.63 to the power T. Okay, this is the last material is sketch relationship. This is some sketch for sin x, cos x, sin square and cos square and tan. And for sin x, the graph is always and the last material is sketch relationship. And here some sketch from sine, cos, sine square, cos square, and tan. And here for graph for sine, the point usually start from 0 and go to up to 1 and go down to 0 and go down again to minus 1 and so on. And for cos, usually start from 1, and for sine square and cos square, same like this graph, like sine and cos, but the wave in the graph is closely. And for tan, this is a combine of graph from sine and cos. That's all from me. Back to GG. Thank you.
So I think that's all from our presentation of our groups about mathematics and physics. The topics are graph. We do really apologize if there's any mistakes from us and our explanation wasn't really clear enough or wasn't that comprehensive for all of you guys. We hope that we will get better in the future. And if there's something misconception about our explanation, we hope that you guys could tell us the right explanation about that. One more time, thank you very much for your attention and see you in the next presentation. Bye-bye. Assalamualaikum warahmatullahi wabarakatuh.